Today on Sci Guys, egg in a bottle. Welcome to Sci Guys. I'm Ryan.
And I'm Adam. On today's episode, we're going to be doing egg in a bottle.
Thank you to Grace for suggesting this episode. It's going to be exactly what you wanted.
More egg puns. The combined gas law incorporates the three laws of gases into a single equation and shows the relationship between the volume, pressure, and temperature of a set amount of gas.
The equipment you're going to need for this episode includes a flask or bottle with an opening just smaller than your egg,
A couple of hard-boiled eggs with shells removed,
butane lighter,
a couple of paper strips,
and because we're dealing with fire, a fire extinguisher.
The safety equipment we're going to need for today includes an apron or lab coat, goggles, and gloves. And, since we're dealing with fire, it's always recommended to have adult supervision.
The only steps for this experiment are to light your piece of paper with your butane lighter, let it catch fire a little bit first, so it's nice and hot, drop it into your beaker and place your egg over the top.
Yay!
Let's try that again, this time with a glass bottle. To remove your egg from your bottle, use heat-resistant gloves or tongs and hold your bottle upside down over some boiling water, with the egg covering the opening. As the air inside the bottle heats up, it's going to force the egg into the opening. Once it gets stuck into the opening, flip it right side up and continue to heat the bottle until the egg pops out the top. Let's look at this experiment a little closer. This experiment is a great example of the combined gas law, which combines the three laws of gases, Charles's law, Boyle's law, and Gay-Lussac's law, and states that the temperature, pressure, and volume of a gas are related. To learn more about the three laws of gases, check out our other videos. Normally, when you place an egg on top of the bottle, it won't fit through the bottle's opening, because the egg's diameter is larger than the opening of the bottle. Since the pressure inside and outside of the bottle are the same, the only force that pushes the egg into the bottle is gravity, but gravity isn't strong enough. Our bottle is full of air molecules. When we drop the flaming piece of paper into the bottle and seal the opening with the egg, the flaming paper heats up the air molecules inside the bottle. When a gas like air is heated, the molecules move faster and try to spread further apart, but because the air is trapped inside the bottle, the volume of space that it can take up is limited. Once the air has filled the volume of the bottle and cannot spread any further apart, the air molecules start to press against the walls of the bottle, and since the walls won't move, the air pressure inside the bottle increases rapidly. As the pressure and temperature of the air inside the bottle increases, some of the oxygen molecules are used in combustion, creating the products carbon monoxide, carbon dioxide, and water vapor. Once the pressure inside the bottle is strong enough, it will cause the egg to jump up and down and allow the air to rush out into the environment. Both of these processes reduce the amount of air inside the bottle, but because the air is extremely hot, its volume still fills the bottle and the high pressure remains. Once the majority of the air molecules have escaped the bottle or are used in combustion, the flame of the paper will extinguish. Once this happens, the air inside the bottle will begin to cool, reducing in volume and pressure. But because we have far less air molecules inside the bottle than when we started, the pressure inside the bottle drops much lower than at the start of the experiment. Because the pressure outside our bottle is higher than inside our bottle, the force the outside pressure exerts on our egg is strong enough to gently push the egg through the small opening and into the bottle. Once the egg is in the bottle, the seal preventing air from entering the bottle is gone, and air rushes in, balancing the pressure inside and outside of the bottle. The opposite effect occurs when we remove the egg from the bottle. As we heat the air in the bottle, the pressure inside gets much higher than the pressure outside. The higher inside pressure generates a much stronger force than the pressure outside of the bottle, gently pushing the egg through the opening of the bottle, until the egg shoots out of the opening, allowing the air to rush out, balancing the pressure inside and outside of the bottle.
Well, that's it for Egg in a Bottle. I hope you enjoyed it.
If you like this episode, let us know in the comments below and subscribe for future episodes.
Make sure to like us on Facebook and follow us on Twitter.
And if you have any questions related to this episode, or about science in general, let us know in the comments below or message us on Facebook and we'll try to help you out as best possible. Thanks for watching. Bye.
Bye.
A little battle scarred, but it made it in and out of the bottle.
Truly a triumph.
Here at SciGuys, we're always curious how experiments turn out. So if you do these experiments at home, share a video or photo of them with us on our Facebook or Google Plus page. But remember to always ask your parents' permission before you share any photos or videos.